What up, nerds? My name is Clay Cooper from Prep Expert. I've got a perfect score on the SAT and a perfect score on the ACT. And today I'm going to teach you how to factor quadratics. Factoring quadratics shows up on virtually every SAT and ACT. Regardless of which of those tests you're taking, you can count on needing to know how to factor quadratics. Now, what you are asked to do with the factors that you find varies depending on what kind of problem you're working on. Sometimes the factors themselves will be the solution to the problem. Sometimes you have to find the factors as part of finding a different solution to the problem. But you can bet that you're going to need to know how to factor quadratics on the SAT or the ACT. It's going to show up, I guarantee it. So let's make sure we got a solid base and we know how to do it. We'll start with an easier one. This first quadratic here on the top has an A term that's equal to 1. Now, what do I mean by the A term? Well, in order to factor quadratics, we have to begin by knowing the standard form of a quadratic equation. That is ax squared plus bx plus c. When you have a quadratic in the standard form, what that means is you have a single x squared term, and that x squared term has a coefficient that we call the A term. You have a single x term. That x term has a coefficient that we call the b term. And you have a single constant added on the end that we call the c term. Now again, in this form, a, b, and c are all constants, which is to say they are all numbers. They're not variables, they are just numbers. We might not know what number they are in the moment, that's why we call them constants, but they are just numbers, not variables. A lot of times when I'm factoring, it will be the case that the equation, the quadratic equation that I'm factoring is set equal to 0. When the quadratic equation that I'm factoring is set equal to 0, the factors that I find, as we will see, are themselves solutions to that equation. Now, that's not always the case. It won't always be the case that my quadratic is set equal to 0. And if it's not set equal to 0, then the factors I find are not themselves a solution to the equation. They might be the solution to the question, depending on what the question's asking me. Or they might just be a part of the process, as we've discussed. So, let's start, though, by making sure we know how to actually factor the quadratic. It's really easy to factor a quadratic when your x squared term has a coefficient that's equal to 1. As I mentioned, when the a term is equal to 1. In this case, that's exactly what we have. Because the a term here doesn't show up, that means it is in fact equal to 1. When x squared is just shown by itself without a coefficient, that means its coefficient is actually 1. So that makes this a lot easier. When it is the case that your a term is equal to 1, all you have to do is look for two factors of the c term that add up to the b term. It's important, as you're looking for two factors of the c term that add up to the b term, it's important to keep in mind the signs of both the c term and the b term. Are they positive? Are they negative? What are they? So in this case, we're looking for two factors of positive 21 that add up to negative 10. Because they both multiply together to give me a positive number, but they add together to give me a negative number, I know they must both be negative. I know that the only way two numbers can multiply to give me a positive and add to give me a negative is if they are in fact both negative. If one of them was negative and one was positive, their product would be negative. If they were both positive, their sum would be positive. Neither of those are the case here. Because we have a positive product and a negative sum, we must have two negative factors. So I don't know what my factors are yet, but I do know they're both negative. Now, let's take a look at what they could be. Can you guys think of two factors of 21 that add up to 10? Let's start just by naming two factors of 21. I only know two factors of 21. So I'll start by writing out my 3 and 7 next to my equation. I know that 3 times 7 does multiply to equal 21. Does 3 plus 7 add to equal 10? Yeah, it does. Absolutely. So now I just got to figure out the signs. But we've already done that. We know that the signs of both of these must be negative. So I'm going to plug them in, and now if I wanted to double check that I got the right factors, I could FOIL out these two binomials and basically reverse the process and make sure they give me the right quadratic. So if I FOIL them, x times x is x squared, x times negative 7 is minus 7x, minus 3 times x is negative 3x, and negative 3 times negative 7 is positive 21. So adding that together, I get x squared minus 10x plus 21. So it's really that simple when your a term is 1. We've got two factors that add up to the b term and multiply together to equal the c term. When I find those two factors, those are the second term in my two binomials that are the factors of that quadratic. And again, if that quadratic is equal to 0, then these two factors that I've just found reveal the two solutions to the equation. So let's clear some space here and I'll show you what I mean. When the two factors are multiplied together in an equation that is equal to 0, well, 0 has special properties. That's one of the reasons factoring is so useful. In other words, if it were the case that the left binomial equaled 0, then it doesn't matter what's in the right binomial. The product is still 0. In other words, if I can make this binomial equal 0, then the equation is true, regardless of what happens over here. And the reverse is true as well. If I can make the right factor, the right binomial, equal to 0, then the equation is true, regardless of what's happening in the left binomial. And that's why each of these binomials by itself represents a solution to the equation. How do I find them? Well, what do I need to make x minus 3 equal 0? Well, now I can just add 3 to each side and I see that I get x equals 3. So it looks like x equals 3 is one of my solutions. I can do the same process for the other binomial, x minus 7. When x minus 7 is set equal to 0, I add 7 to each side and it becomes clear that x can also equal 7. So it looks like my two solutions to this quadratic are x equals 3 and x equals 7. If you notice, those are the same as the two factors of the quadratic, just with their signs reversed. Now let's talk a little bit about a harder form of factoring. Sometimes you'll get a quadratic like this one below in which the a term is not equal to 1. We have to use a slightly different method when the a term is not equal to 1, but you can handle it. Let's pay attention. Here's how it works. First, I'm going to multiply together my a term and my c term. In this case, that is 6 and negative 3. When I multiply 6 and negative 3 together, I get negative 18. Now I found what a times c is. I know what my factors have to multiply together to be. I'll now turn my attention to the b term. I know the b term is negative 7. It is still the case that my factors must add up to produce negative 7. What I'm going to do now is look for two factors of negative 18 that add up to negative 7. Can you think of any? Well, first let's consider their signs. In this case, my product, negative 18, is negative. For a product to be negative, that means that one of my solutions must be negative and the other must be positive. That's the only way I can get a negative product, to have a negative factor and a positive factor. So I know that their sum here is negative. If they add together to give me a negative sum, that means the bigger number must be the negative number, because when I add them together, I've still got negative left over. It kind of outweighs the positive number, so to speak. Now, how do I find out what those factors should be? Well, I know that these numbers 6 and negative 3 multiplied together to give me negative 18. I'm now going to look for two factors of negative 18 that will add together to give me negative 7. Can you think of any? I only know a couple pairs of factors for 18. One of them is 2 and 9. If one of those were negative, that would give me negative 18. Let's call it negative 9. And if I add together 2 and negative 9, what do I get? Negative 7. So it looks like 2 and negative 9 are in fact the beginning steps here. They're the factors that I start with. Awesome. Now, what I do is rewrite my b term. It started as negative 7x, but I've identified the two factors that I need from that b term. What I do is split up that negative 7x into negative 9x plus 2x. And if you notice here, I'm not cheating because negative 7x is the same thing as negative 9x plus 2x. When I do that, I see that I've got 6x squared minus 9x plus 2x minus 3. So I've got 6x squared minus 9x plus 2x minus 3. What do I do now? Well, now I'm going to factor by grouping, which means I'm going to ignore the two terms on the right for just a moment and factor the two terms on the left. Can you guys think of any factors that 6x squared and negative 9x have in common? I think definitely 3, and it looks like an x as well, actually. Looks like they're both multiplied by 3x. Okay, cool. When I factor 3x out of 6x squared, what's left? I think it's going to be 2x. And when I factor 3x out of negative 9x, what's left? Just negative 3. Awesome. So I have factored the two left-hand terms. All right, now I'm going to cover them up and factor the two right-hand terms by themselves. All right, it doesn't look like 2x and negative 3 have any terms in common. So I'm going to leave them as they are, 2x minus 3, and just write a 1 outside of it. In other words, 1 on 2, 2x minus 3, is the same thing as 2x minus 3. The reason I put them in parentheses and leave a 1 outside of it is because now I have two terms left, two big terms, this one and this one. Do those two big terms themselves share a term that I can factor out? They do. 2x minus 3. Both of them are multiplied by the binomial 2x minus 3. So if I factor that out of the overall equation, what's left in the first big term? 3x. And what's left in the second big term? 1. 3x plus 1. So now I have, in fact, factored my more difficult quadratic whose a term is not equal to 1. I can see that if I were to FOIL this in reverse, 2x times 3x is 6x squared. 2x times 1 is 2x. Negative 3 times 3x is negative 9x, and negative 3 times 1 is negative 3. So simplifying a little bit, 6x squared minus 7x minus 3. That is, in fact, the exact same binomial I started out with. So I factored it correctly, which is really cool. Now, as we discussed earlier, what you'll actually be asked to do with the factors you found varies based on what kind of problem you're facing. But now that you know how to factor quadratics, you're in really good shape to get these problems correct. And that's all you need to know to factor quadratics on both the SAT and the ACT. Don't forget to throw us a like if you found this video helpful. You can also subscribe to Prep Expert's YouTube channel for other videos just like this one. In fact, I'd love it if you'd leave me a comment below this video and let me know what you want to hear about in our next video. What do you want advice on from a 2-time perfect scorer? There's also a coupon code in the description below this video that you can use to get discounts on all of our products on our website, prepexpert.com. You can sign up for a course with myself or another instructor, or you can sign up for tutoring if you'd prefer that. So until next time, keep working hard.